Hello guys, I am Ali Jawad and welcome to my YouTube channel. In this video, we will discuss lesson number 3 on chapter number 17 Magnetism of Physics syllabus 5054 for O-level students. Those who are new to this video, they are recommended to go through lesson 1 and lesson 2 before continuing with this video so that they may get the basic introduction of the chapter. I am giving the link in the description as well for lesson 1 and lesson 2, and you can also click here in the video. We have already discussed some of the basic points related to magnetism in our lesson number 1 and lesson number 2. The topic for today's discussion will be magnetic field. So, what is magnetic field? When we place a magnet, there is a region around the magnet in which its force of attraction or repulsion could be felt. That region around a magnet is known as magnetic field. So, how to locate and draw the magnetic field patterns of different magnets? Let us investigate that. This is an instrument known as compass. It is actually a magnetized needle pivoted on a point like this, so the needle can turn. As you can see in the picture, the magnetic needle deflects. Red arrow is representing the North Pole, while the blue one is the South Pole in the compass shown at the right side. So the needle was deflecting according to the compass. So we can use the compass to get the direction of North and South pole of the magnet. So if we want to draw a magnetic field of a bar magnet, we can place a bar magnet over a paper, and after we can place a compass at this particular point. As the arrowhead is showing the North Pole, so it will repel by the North Pole of the bar magnet and it will point in the opposite direction. So we can mark a point with a pencil like this. Now we can change the location of the compass, and again the arrowhead representing the North Pole will point away from the North Pole of the bar magnet. We can also plot 2 points with the help of pencil. If we may go on repeating the process for several locations, we can get different points where the needle is being deflected because of the forces of attraction between the magnet and the needle itself. And this is how we will be able to locate the magnetic field of a bar magnet like this. So this kind of pattern can be obtained by placing the compass at different locations and marking the points with the pencil. When we will connect all the points with the pencil and also indicating the direction of the needle with the arrow, we will get such a figure. This is known as the magnetic field of a bar magnet. We also have different types of magnets which are produced by the effect of current. So we can also find the direction of those magnetic fields with the help of this instrument called compass. For example, a straight wire carrying a current also has a magnetic field around it. So for example, if the current is passing in the downward direction, we can use the compass as shown in the figure to plot the magnetic field. As you can see here, the magnetic fields are in circular pattern. So how we can summarize this? This can be summarized with the help of right hand rule. What does right hand rule mean? The thumb of your right hand indicates the direction of current, while the curl of your hand indicates the direction of magnetic field. So if the thumb is pointing in the upward direction, then the curl of the finger will give the direction of magnetic field. Similarly, if the thumb is pointed in the downward direction, then again the curl of the right hand will give the direction of magnetic field. So the arrowheads are representing north and this is representing south. Similarly, for a solenoid, when the current is allowed to pass through the coils, we can also use this right hand rule to find the direction of magnetic field. In the case of coils, it is not similar to the straight conductor. Now the curl of the finger will represent current and thumb of the right hand represents the direction of north pole. For instance, if the current is passing in the direction shown in this figure, then take your right hand and curl your finger in the direction of current. The thumb will point in the direction of north pole. Similarly, if you are having a piece of conductor around which a coil is wounded and the direction of current is such that as shown in the figure, then the curl of your right hand will give the direction of current while thumb will give you the direction of north pole. At this point, we need to keep in our mind that the direction of the magnetic field is from north to south, as it was in the case of bar magnet. Let us go back to the bar magnet, for instance. As you can see, in the case of bar magnet, the direction of current was, the direction of magnet was from the north and it is bending towards the south. While if you will try to locate the direction inside the magnet, it will be from south to north, like this. So, if we may go back to the case of solenoid, over here, the direction outside the coil will be away from the north pole and towards the south pole, just like the direction of magnetic field of a bar magnet. However, from inside, it will be from south to north. Same goes in this case. The inside magnetic field will be from south to north, while the outside magnetic field will be from north to south pole. Thank you for watching the video. I hope that you might have enjoyed this lesson. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you for watching this.